Okay, I remember that we are doing number, so the next one is 28, right?
Yes.
Sine 15 degree.
27, Professor. I think it's 27.
No, I saw in the video. 27 I did that. Now 28 now.
Yes, it's 28. Sorry, it's 28.
Okay, so now we practice a little bit the sum of differences, no? Formulas. In this case, the combination que match perfect is 45 and 30. So 45 degree minus 30 degree is 15 degree. So you replace no sine 15 anymore, it's sine 45 minus 30. And we're using the formula que state the relationship when you have subtraction to angle. Es sine 45 multiplication cosine 30 plus sine 30 45, well, sine 30, yeah, and cosine 45 degree.
Wouldn't it be subtracting?
Say again?
Wouldn't it be subtracting?
Because I need to find sine 15 degree. In my mind, I break it down 15 like a 45 minus 30. Make sense? It's equivalent.
Yeah, but in the formula, it's supposed to be subtracting, but you wrote
No,
addition.
no, it's plus. Let me show you, miss. This is important detail. Thank you for asking me this. This is super important detail. Look, let me try to find the cheat sheet to show you specifically that formula or that identity. Wow, wait a second. Boom. Okay, the most important page is the second. Look at that, miss. When there's minus, look, make it zoom. It's sine. When it's minus. Oh, yeah, you're right. You are right, no? It's minus. It's minus. You're right. Sorry. Sorry, you're right. It's minus. I believe, I don't know, it's cosine, but it's sine. You're right. It's minus. Oh, yes. Okay. You're right, miss. Super. Thank you. It doesn't minus here. F minus. I don't know why. In my paper, I put plus. F minus. F minus. F minus. F minus. Okay. Okay, now you compute separately. Sine 45 degree is radical 2 over 2. Cosine is radical 3 over 2. Cosine 30 degree. Minus 1/2 times radical 2 over 2. So in the top you have 4. So we have radical 2, radical 3. Minus radical 2. I don't know, so leave it like that, or factorization radical 2 outside, radical 2 is radical 3 minus 1 divided by 4. Let me see what option is C, no? Is, let me see, because I make a mistake on the sign. Yeah, it's C, it's C. Any question, right? That was 28, no? 28 question. No, 29. No question? Okay, I need to compute now sine 165 degree. Well, in this case, I try to find the combination. The combination is 120 and 45. Addition plus. So you break it down, sine 160 like a 120 degree plus 45 degree. And we apply again the same formula, but in this case plus. So sine 120 multiplication cosine 45 degree plus sine 45 degree times cosine 120. Okay, keep in mind that 120 lie in the second quadrant. If sine is positive, but cosine is negative. Okay, sine 120 is a radical 3 over 2 positive. Cosine 45 is radical 2 over 2. Plus sine 45 degree radical 2 over 2 and cosine 120 is negative half. It's negative half. So now again multiplication, 2 times 2 is 4 and the denominator is 4 because it's 2 times 2. Radical 3, radical 2, minus because plus and minus radical 2. If you want factorization radical 2 outside, it's radical 3 minus 1 divided by 4. Wow, it's similar answer, right? It's the same answer. 15 and 165. It's the option C, I guess. C. C. Yes, let's see. It's this one. And this was this. It's the same, identical. Identical. Easy or no? Okay, one more, 30. 30 is computed cosine 285. Bueno, 85 I get, remember the hints to recognize the combination is when the ending in 5 es que participe 45. Entonces 240 and 45 together is 285. Immediately right, cosine 240 plus 45 degree. We use the formula is cosine 240 multiplication cosine 45. Now in this case, yes, it's minus. When it's plus, it's minus and cosine. This is the formula. So we have sine 240 and multiplication sine 45. Okay, remember que 240 lie in the third quadrant. In this case, cosine and sine are negative, but negative 1/2. Negative 1/2 is cosine. This is the famous radical 2 over 2 minus this is negative radical 3 over 2 because 240 somehow is related with the 60 degree, que is the reference angle. No? 240, let me see, 240 lie here, 240 degrees, approximately, not exactly, but approximately. And the reference angle, que is this guy, is 60. So somehow, any trigonometric function for the 240 and the 60 degree have the same value. Not the sign, but the value, yes. So you take like reference 60. And to say you remember or you don't remember, or you see the chi, whatever, the value. Okay, it's cosine 60 is 1/2 and sine 60 is radical 3 over 2, no? And this is radical 2 over 2. Now this is positive because it's in the first quadrant. So again, happen que 2 times to the 4. We have minus radical 2 and double minus become positive radical 2 radical 3, no? So you factor out radical 2. We have negative 1 plus radical 3 divided by 4. Oh, one elegant way to write is radical 2 radical 3 minus 1, que is the same, no? I switch the order. I put the positive first, because it's more elegant. No? But that is the answer. It is coincident with the option D, no? I guess so. Let me check it out. At least in my paper, I put D. Oh, yes, it's D. It's this guy. Any questions so far? Any questions so far? Any questions?
So can I take a picture? I have a question. So, Professor, when we have an angle, how we know that when we break that angle, we're gonna use like those specific numbers? For example, you have 285 and you put 240 plus 45, but how are we gonna discover that are the values?
Okay, I give the hint that when the number ending in 5 is because participate 45. And remember the collection of the angle que es fundamental, que es 30, 45, 69, 120, 135, 100, 150, 180, 210, 225. This is the fundamental in which you know very well any trigonometric function. You try to find combination. There are no recipe for that. Using common sense and imagination, okay? 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 You understand?
Yes, Professor, I did.
Okay. Let's continue to the next page. Page
So,
number 4.
Professor, just to make sure, like when we have a 5, we need to always use 45 with and try other angles as well, right?
Well, okay. Or ending in 5 is maybe 45, or maybe 135, or maybe 225, or maybe 300. 315 is another possibility, ending in 5. Okay? But I like 45 because it's in the first quadrant, it's easy, no? And try to find the combination with another. Okay? However, the answer is completely independent, the combination, because the mathematics is exact sign, no? So you select another combination, of course, good combination, and always work. Let me see what the next. Next, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, this is 4. Okay. No, it's not this. It's this. Okay, 31. Yes, it's this. Yeah. Okay, super. Super. Okay, this is a little bit more complicated because we have sine, but it's no big deal. Sine of cosine inverse 1/2 plus no minus sine inverse of radical 3/8. If you want, well, okay, remember one more time, repetition, the answer for the any trigonometric inverse function is give me an angle. I want to call alpha, I want to call beta. Okay, therefore you copy separately cosine inverse of 1/2 is equal alpha, que es equivalent to say que cosine alpha is 1/2. In this moment, I realize when I know que cosine alpha equal 1/2, que of course the value is positive, alpha lie in the first quadrant, it's obvious que alpha in this specific example is pi/3, because I know que the angle whose cosine is positive 1/2 is pi/3. Okay, similar sine inverse of the radical 3/2 I call beta, que es equivalent to say que sine beta is equal radical 3/2. Entonces I know que beta lie also in the first quadrant because sine inverse of the positive value give me an angle always in the first quadrant. And beta in this case is a coincidence que es pi/3. Wow, pi/3 plus pi/3. Ok. Entonces es sine of pi/3 minus pi over 3. Wow. And pi over 3 minus pi over 3 is 0. And sine 0 is 0. Got it? We are doing 31st.
We need to do, Professor. We need to do like to put in radians always, right?
No necessarily, Nuela. I don't know mechanical and doing this, pero no, 60 degree, 60 degree, 60 degree, 60 degree, 0 degree, no radian, 0 answer. Either way, if you prefer degree, there are two different ways to measure angle, radian or degree. You can adapt it in your own way. Basically, in the new chapter, chapter 3, we are working in degree because it's more comfortable to visualize geometrically. Do you understand the problem 31st?
Yes, I did. Thank you.
Okay. Let's move on to the 32nd. Say, wow, is cosine, tangent inversed of 4 over 3 minus sine inversed of 3/5. Again, the same idea. I call alpha, I call beta. This is no mandatory, but however, I need to be familiar with the formula. Entonces, tangent inverse of 4/3 is equal alpha. Another point of view to see the same idea is que tangent alpha is 4/3. And 4/3 is no value inside the fundamental angle because of 1/2, radical 3 over 2, radical 2, no, this is crazy. Entonces, the only possibility we have is do the triangle. Este triangle. The triangle, this is alpha, and tangent by definition is opposite over adjacent, and this is the famous 3, 4, 5 triangle, no? Okay, 5 comes from of the square root 3 square plus 4 square, no? 3 square is 9, plus 4 square is 16, it's a 25, and square root 25, 5. But I know by memory the famous 3, 4, 5 triangle. And for a moment, keep it like that. Stop here. Likewise, in the second part, I saw the sine inverse of 3/5 is equal beta. Or using trigonometry direct function, sine beta is equal to 3/5. Okay, this is no fundamental triangle, so I need to go do my own triangle. It's a beta. Okay, definition is opposite over hypotenuse. And again, this is a famous 3, 4, 5, but in different order. Okay, so now I go to the formula. The formula says cosine alpha times cosine beta plus sine alpha sine beta. Cosine alpha is 3 over 5. Look at the triangle of the alpha. It's adjacent over hypotenuse. Multiplication. Cosine beta is 4/5. Plus sine alpha is 4/5. Times sine beta is 3/5. Exactly the same we have at the beginning. And now the rest is super easy arithmetic. 5 times 5 is 25, it's 12 over 25, plus 12 over 25 by coincidence, it's the same, it's 24 over 25, final answer. Good or not good?
Good.
Okay, that's what 32.
Wait, Professor, in the beginning, It's saying cosine subtracting alpha and beta, like alpha minus beta.
Yeah. At the beginning is minus, miss. That is the reason.
Cosine. Yes, I see. My bad. I see it.
No. It's okay. Okay, 33 now. So you have no question, additional question, no? Okay, go back to the next case. Sine. Let me see the page. Okay, 33. Sine, parenthesis, sine inverse of 2/3. Okay, if you want to put a parenthesis here, it's more properly, more clear. But it doesn't matter. Plus cosine inverse of 1/3. Close the parenthesis for this function and close the parenthesis for that function. We have three functions, two inversed and one direct. I call this guy alpha. I call this guy beta because I know que the answer que offer the inverse trigonometry is angle. Okay, entonces now I declaré que sine inverse of 2/3 is alpha. Or equivalent statement, sine alpha equal to 2/3. This is not equal any angle que you know the fundamental. This is completely crazy, but no problem when you have no idea. Well, one possibility is doing by calculator, no? But in the calculator, the majority of the calculator give me the answer in decimal approximation. I need in that part exact answer. To say exact answer without calculator. You see que sine, si you define que this is alpha, sine is opposite over hypotenuse. I have to find another let because we need definitely s square root 3 squared que es 9 minus 4 que es 2 squared, es radical 5. And for a moment, leave it like that. We dedicate the time now for the beta. Cosine inverse of 1/3. I call beta. Or the same idea que cosine beta is 1/3. We have another triangle. We have one triangle, guys, for the alpha and one triangle for the beta. Separately, different triangle. Cosine is adjacent over hypotenuse. And the other guy is square root 3 squared is 9 minus 1 squared is 1 is radical 8. And radical 8 is 2 radical 2, no? Because you know the 8 is 2 and 4. And you apply square root both number, entonces radical 4 is 2, is the 2 outside, no? Okay, entonces we have to complete the triangle. When you have completed the triangle, you will be able to find any trigonometric function involving my formula. And my formula is sine alpha multiplication cosine beta plus sine beta times cosine alpha. Okay, sine alpha, bueno, is given at the beginning at 2/3. Cosine beta is 1/3. It's also given at the beginning. Plus sine beta is 2 radical 2 divided by 3. And cosine alpha is radical 5 over 3. Fortunately, the numerator is the same. 3 times 3 always is 9. You have 2 plus 2 radical 10. And radical 10 comes from the combination radical 2 and radical 5. Each one, no? Condensing in only one. Entonces es 2 plus 2 radical 10 over 9, que es the option B. Let me check it si I select well in my paper or no. 2 plus 2 radical 10 divided by 9. Super. Any question?
Sorry, Professor, can I take a picture?
Mm-hmm.
Okay.
Okay.
Okay, thank you. I ready to.
Mm-hmm. Now we have tangent of tangent inverse of 3/4 plus sine inverse. You see this problem is horrible because combine any trigonometry direct or inverse function. So basically we have 6 trigonometric functions, and now we have 6 more inverse trigonometric functions. In total 12 trigonometric functions, direct and inverse. Wow. Again, I call alpha, I call beta, tangent inverse of 3/4 is equal alpha. Is the equivalent to say que tangent alpha is 3/4. Our triangle look like that. 90 degrees, this is alpha. You know the alpha I call this corner, always this corner. And tangent by definition is opposite over adjacent. The hypotenuse 5 is the classical 3, 4, 5. When you have the 3 sides of the triangle, you will be able to find any trigonometric function. Sine, cosine, tangent, cotangent, cosecant. And likewise, sine inverse of 1/2 is equal beta. In this case, is sine beta is equal 1/2. Well, in this case, you don't need to do the triangle because I know that beta is 30 degrees, no? Because it's fundamentally, I know that sine 30 degrees is 1/2. So you're doing a triangle, it's okay, but no, you don't. Okay, now let's go to the formula. The formula for the tangent alpha plus beta is tangent alpha plus tangent beta divided by 1 minus, you see cause when it's plus here, it's plus in the top, but it's minus in the bottom. When it's negative, it's completely opposite. Multiplication tangent alpha, tangent beta. Let's do it. Who is tangent alpha? Bueno, tangent alpha is 3/4. Plus. Who is tangent beta? Bueno, tangent beta is tangent 30 degrees. Okay, I know by memory or checking in this unit circle, whatever you want on the table is radical 3/3. In the bottom we have exactly the same minus, but a multiplication is 3/4 times radical 3/3. It's okay? Well. So now you try to, this is the answer of that. This answer is really ugly, you know? You cancel out this 3 and this 3, why not? And you condensing the fraction in the top. LCD is 12. 12 divided by 4 is 3. 3 times 3 is 9. Plus 12 divided by 3 is 4. 4 times radical 3 is 4 radical 3. And the bottom we have 1. Let me go over here. 1 minus radical 3 over 4. Because this 3 disappears. That's a 4. It's 4. So we have 4 minus radical 3. Something like that, right? Okay, now continue is, I copy the first fraction exactly the same. 9 plus 4 radical 3 divided by 12. And you flip it, that 4 over 4 minus radical 3. Entonces you see que this is cancelled. This is divided by 4 is 1, divided by 4 is 3. And so far the answer is 9 plus 4 radical 3 divided by, well, 3 or 12. It doesn't matter. 3 times this, or you distribute it, is 12 minus 3 radical 3. You can continue simplifying. You can, of course. You can rationalize. But no. I come back to the page to see the multiple choice. I see the option B matching perfectly with this idea. Option B, no? Option B, there you go. This one. Super good. Super good or no?
Yes.
Yes.
Excellent. I want to hear that. Okay, now we practice a little bit double angle, half angle formulas.
This is the last part of the package, right, Professor?
I suppose, no? No,
Yeah.
the last part is the equations. The last part is the equation. Suppose que we don't finish. Entonces we need to, don't worry for this. I am trying to do my best for my students. Maybe Tuesday we finish the part of the review and we extend it a little bit, but no, I don't know. Let me think it positive, not negative. Okay, the 35 problems say sine theta is given is 3/5. And also is given que theta is in between 0 and pi/2. In other words, theta lie in the first quadrant. Okay? Entonces, any trigonometric function que you manipulate in this example is positive. Entonces, I know this identity. I see in my cheat sheet. You need to find cosine double angle to theta. There are three identities that state this relationship. You use it either way, the answer doesn't change, it's the same. However, in my mind, I don't know why, I prefer the first one, que es cosine squared theta minus sine squared theta. Remember, it's completely different to the identity. The identity is plus, or the plus is 1, independent of the theta. But when it's negative, no, it's double angle. Okay, so the only thing you should do is do the famous triangle for the theta. This is theta now. And sine is 3, que is opposite over hypotenuse. And this again is a famous 3, 4, 5 triangle. No? So we are ready to complete everything. Cosine is adjacent over hypotenuse. Is square. Don't forget this is square. Sine, well, sine is given. It's 3/5. It's square. This is 16/25. This is 9/25. And this is 16 minus 9, que is 7/25. And the beauty of the double angle formula is that you don't care in what quadrant lie theta, because the formula guides you to the signs. You don't care. You don't know, because actually it's ambiguous. Suppose that you multiply this inequality by 2 in order to investigate 2 theta in what quadrant lie. You multiply by 2, you have 0 less than or 2 theta less than pi. And this is totally ambiguous because lie in 0 and pi. So it's maybe in the first quadrant or in the second quadrant, according to this interval. Huh? However, for sure, I guarantee you 100% that lie in the first quadrant because the value is positive. No? So you don't care. And the half angle, yes, because the half angle formula has plus or minus. So you need to determine if it's plus or minus. But in double angle, no. Ahí mechanically I'm doing. Si the answer is positive, positive. Si the answer is negative, negative. That's it. Got it? Okay. That was example 35. 36. And 36 is given the cosine is 12/13. And they want, can you find sine double angle? So my goal is sine double angle. I have no idea. And the formula is easy. The formula is sine double angle. We have only one unique formula, 2 sine theta multiplication cosine theta. Okay, I have cosine in my hand, but I need to find sine. The efficiency way to do this is using the triangle. Okay, this is my theta, 90 degrees. Cosine by definition is adjacent over hypotenuse. Now for finding the other leg, 13 squared minus 12 squared. This is 169, this is 144, subtracting is 5, it's 25, and the answer is 5. Okay, now it's 2 times the sine is opposite over hypotenuse. And cosine is, well, cosine is given, it's 12 over 13. If you multiply 2 times 5, get 10, times 12 is 120, and 13 times 13 is 169. And the answer is positive. That means that this angle also lies in the first quadrant. Super good?
Yes. So, Professor, I do have a question. When we see like, because on homework, I had a question. I had that, the first one actually, that you saw. So we need to see like, if it lies on the first, second, third, or fourth, so we can determine like the value, if it's negative or positive on the final result, right?
No.
No, Professor, I'm talking about the first one, not like this one that you solved.
The first and the second. Neither first neither second. Look, neither. When you are using double angular formula, you don't care the sign. The sign is given directly for the mathematics. The mathematics give me the information. It's negative or positive. Okay? In double angular, in half angular, no.
Okay, I got you. Thank you.
Okay. Okay. This was 36, no? Okay, 37 now. 37 say tangent theta is equal to 15 over 8. Entonces now, maybe to confuse you, give me this information. Theta lie in between pi and 3 pi over 2, no? By the way, well, no to confuse you, no, it's useful information. Is basic, you need to find sine, no? Sine, you need to find sine, yeah, sine 2 theta, sine double angle. Okay, it's the same formula, no? It's 2 times sine theta cosine theta. But I need to know for this information that my angle lie in the third quadrant, no? My angle lie, theta lie in the third quadrant. Bueno, eso, bueno, no, it's not obvious, pero es logical, at least, because the tangent is positive, no? Y I suppose when I compute sine and cosine separately, it's negative both. A negative time, negative, positive. This is the reason. I don't know. Let me try. So I do my triangle. Boom. Is it theta? Remember, I don't care the actual position. My triangle always am supposed to in the first one. I saw a student doing like that. No, this is crazy. No. Not good. Okay, so now the tangent is the ratio between opposite and adjacent. To find the hypotenuse, the third guy I need to find is a squared, que is 64, and 15 squared, que is 225. Together, when you adding and find the square root, is 17. You can verify in your own calculator. Okay, entonces now, suppose que I need to compute sine theta. Well, sine theta is 15 over 17, right? 15 opposite over hypotenuse. But you need to know que es negative. Because in the third quadrant, the sign is negative. So you adjust the sign. A cosine is A, que es adjacent over the hypotenuse, but again it's negative. But I don't care, because negative times negative is positive. Well, okay, not always, but in this case, yes. because my angle, my double angle may be lie in the second quadrant or in the first quadrant. I want to investigate after. But it's not important. It's not important. And you multiplication 2 times 15 times 8, 16 times 15 is 240. Divided by 17 times 17 is 289. That is the answer. So the challenge is this angle would be in the first quadrant or in the second quadrant. I have no idea. But don't worry. Look, so you take this inequality and multiplication by 2, you have to buy theta, and it's a 3 pi. Yes or no? Sorry, I forgot to here. You multiply. There's a basic is 2 pi, 2 pi, 2 pi, 2 pi here and 0, and 3 pi is pi, just 1 pi. The idea que es ambiguous is first quadrant or second quadrant. By the way, in both scenarios, the sign is positive. Clear?
Clear.
Yes.
Okay. Okay. What is the next? 38, no? 38. Oh, I don't erase anything. Okay, 38. Okay, erase now. Guys, it's no big deal. You need to get the algorithm, the procedure, the mechanic. It's no super science fiction, no. You apply the formulas and the basic idea that we studied in the chapter 1, the signs of the trigonometric function of any quadrant, etc. Okay, 38 is given the sine. Sine theta is 1 over 4. And theta lie. So this sometimes explicit, sometimes no. Es expressed the location of the theta angle that you're reaching, in the like inequality format, no? I need to find sine half angle. Entonces the formula for the half angle is plus or minus square root 1 minus cosine theta divided by 2. And the challenge is what sign are you using, plus or minus. So in this case, you need to determine specifically in what quadrant lie the half angle. So in what quadrant lie this guy. Because I know that this guy lie in the first quadrant. According to this idea, no? Half angle, si es smaller, no? It's a half divided by 2, I suppose que lie in the also first quadrant, but no, okay, in order to see more clear, you now take this inequality and divide it by 2. 0 divided by 2 is 0. Theta over 2, because and divided by 2, and this is 1 pi over 4, right? So my theta angle lie in the first quadrant. Look here, this is my theta. However, my half angle associated with this lie in between 0 and pi over 4, 45 degrees. It's obvious again, it's in the first quadrant. Everything is first quadrant in this example. First quadrant, both guys. Now immediately I remove the sign, no negative, plus, because I know in the first quadrant any trigonometric function is positive. One of the challenges is to find the cosine. Well, this is easy. So you are doing the triangle for the theta. The sine is 1 over 4. And the other guy is square root 4 squared is 16 minus 1 is 15, square root 15. Okay, square root 15. So now cosine theta is 15, square root 15, sorry, divided by 4, get the hypotenuse, no? You substitution that number here. And we have so far Square root 1 minus square root 15 over 4 divided by 2. Well, there are many ways to do this. Okay, one way to simplify is if you, for example, there are many ways. Well, let's see the easy way. You multiply by 4. You multiply by 4 top and bottom. What's the idea? What's the intention? The intention is eliminate the fraction. Entonces, you have square root 4 times 1 is 4, and this 4 is cancelled. That was the intention. And the bar we have 8, no? Okay, it's 4 times 2. I'll leave it like that. Now let me see what part I did not wrong. Yeah. No, it's okay. Oh, wait a minute. It's okay. This is a potential solution. However, this is okay. I don't know if this matching or not with this answer. Let me see. No, because 8 is 8 is. Let's see what's going on. Yeah. Because you. Yeah. Okay, now this is perfectly. This is algebraically the same. However, remember this a is inside the root. Entonces basically we have maybe square root 4 minus radical 15 divided by radical a, ¿no? Pero radical a es 2 radical 2. Entonces is radical 4 minus radical 15 divided by 2 radical 2. Well, entonces now rationalize maybe. Radical 2. You put the radical 2 is inside the radical in the top. Entonces actually it's radical 8 minus 2 radical 15. In the bottom we have radical 2 times radical 2 is 2 and 2 times 2 is 4. Got it, more clear. This is the option A. As always, guys, don't complicate too much your life. Well, you try to do your best, no? Because you practice, no? Entonces, the formal mathematics have a specific language. So you leave it like that. I understand. However, I am sad. This is my face, look. Okay? However, see, you get the final answer. I am happy. But either way, you have 100 points. Okay? It's the only my emotion is the only change. Confusion or clear? It's a 38, no? Yeah.
It was clear. Professor, can I take a picture?
Yeah. But before I take a picture, I remove the happy face, no? Or the sub face. Go ahead, take a picture now.
Okay.
Okay, 39.
I took it. Thank you.
39 now. 39 now. Okay. And 39 is given the sine. So we are working using the formula of the half angle. 1/4. In this case, the information is given as a tangent, the original theta, no half, is positive. You need to find cosine. Cosine, no? A cosine, yes. The formula is plus or minus square root 1 plus. It's the only difference is plus or minus. Okay, to say, first of all, before do anything, I need to investigate in what quadrant lie theta. Bueno, theta lie, I suppose in the first quadrant, no? Because sine is positive. Look, sine is positive. It's given as 1 over 4 positive, and tangent is positive. And tangent is positive in the first quadrant, in the third quadrant. But sine is negative in the first quadrant. So the coincidence, two conditions together and give me first quadrant. First quadrant, then theta lie in between 0 and pi over 2. Now half angle lie in between pi over 4. Again, it's similar. It's the first quadrant. So immediately I remove the sign. Yeah, I know that my answer is positive. And you want to put a positive sign, no? But si es omit, si es missing, you understand que es positive. Okay? Let's move on to determine cosine. Cosine is, this is my famous theta. This is sine, get 1, 4 here. And this is, I did before, it's radical 15, no? 16 minus 1, square root 15. So therefore, cosine theta is square root 15 over 4. So we have square root 1 plus square root 15 over 4 divided by 2. Similar, no? Similar manipulation that I did before. Is, now let me try to do fast. Multiply by 4. We have square root 4 plus radical 15 over 8. This is square root 4 plus radical 15 over 2 radical 2, que es radical 8. Rationalize, multiply by radical 2, radical 2. Then you have 4. You have 4. Let me see. Radical 2, radical 2. Yes. No, multiply by is 8, no? Because it's radical 2 outside, sorry. When you put this radical 2 inside, it's like a 2, no? Entonces 8 plus 2 radical 15 divided by 4. Because radical 2 times radical 2 is 2 y 2 times 2 is 4. Ese es the answer, que es the option D, I guess. D, no? Let me see. Oh, yes. No. Es C, ¿no? Es C. Es C. No D. Es C. Let me fix in my paper. It's not D. Es C. Okay, 40. It's 40, no? No, 30, 30, 30. 40, 40. 40 I have back. Well, let me see. This is 39, huh? The up page is finished. Okay, now 40. 40 is the next page. May I erase everything? Yes or no?
Yes.
Okay. Wow, last page. I suppose it's the last. No, it's not the last. Is this, I guess, no? Yeah, almost the last. Okay, entonces now 40. Okay, super. 40 say cosine theta is equal to 1 over 4. Cosecant theta is positive. Find sine theta over 2. Okay, cosine is positive in the first quadrant and in the fourth quadrant. Cosecant is positive in the first quadrant and in the second quadrant. The coincident two conditions is in the first quadrant. Therefore, the conclusion is theta lie in the first quadrant. First quadrant means que theta is in between 0 and pi over 2. The half angle is divided by 2 is in between 0 and pi over 4. Okay, entonces lie also theta over 2 lie also in the first quadrant. Now in the formula you put the positive signs, not the negative signs. The square root 1 minus cosine theta divided by 2. And cosine theta is given, no necessary triangle, is 1 over 4. Entonces square root 1 minus 1 over 4 divided by 2. Well, you combine 1 minus 1 over 4 is 3 over 4. Square root, big square root, 3 over 4 divided by 2. Well, it's 3 over 8, no? It's 3 over 8, it's square root 3 over 8. Where come from 8? 4 times 2 in the denominator, right? Entonces radical 3, and this is 2 radical 2. Rationalize maybe, radical 2 is radical 6 over 4. Because radical 2 times radical 2 is 2, 2 times 2 is 4. This is the answer, radical 6 over 4, que es the option A. Boom. Very good. Any question?
So my question to you is, Professor, we need to first analyze the condition, right, to start doing the exercise so we can determine if it lies on the first or second or third. Okay.
Yeah, the problem is that we have two formulas, one con plus and one con negative. So you need to decide what you select. Entonces now, always is giving information to determine the position of theta, the original theta. But it's easy because when you divide by 2, you get the position for the half angle. In this case, it's not ambiguous, like a double angle, right? It's explicit determining. Clear? So this is the moment, Noela, que you select the positive or a negative. Okay, and you keep going. The problem. Okay, now number 41 is tangent theta is equal to 12 over 5 semicolon, and theta, the original theta, as the information is given, lie in the between pi and 3 pi over 2. In other words, it's in between 180 degree and 270 degree, que es the third quadrant. This is the information for the original theta. However, I need to find sine half angle. To find the location for the half angle, you divide by 2. This is pi over 2 theta, and this is 3 pi over 4. Let me try to see. Pi over 2 here, 90 degree, and 3 pi over 4 is here. This is 90 degree, and this is 135 degree. The location for the double angle is here in the second quadrant. Entonces now, definitely, tangent in the second quadrant, or mejor dicho, sorry, sine in the second quadrant is positive. Again, one more time, we select the positive sign. So is the formula that we're using is the square root 1 minus cosine theta divided by 2. You see that?
Yes.
Okay, entonces determine the cosine is pretty easy because I know the information for the theta, que is opposite over adjacent. In order to find the hypotenuse, you take 5 square plus 12 square, 25, 144 together, and square root is 13. 13. Entonces cosine theta is equal 5 over 13. It's a number I put inside the formula, no? Is square root 1 minus 5 over 13 divided by 2. Well, in this case, let's do in the same procedure. There are many ways to fix it. However, so you multiply by 13 here and 13 here, because my goal is to eliminate the fraction. 13 minus 5 divided by 26. 13 minus 5 is 8, no? It's 8. It's 8 divided by 26. We can reduce on lower term this because it's even number. This is 4 and this is 13. This is square root 4 is 2 and square root 13 no. Rational line. The answer then is 2 radical 13 over 13. And the answer for sure is positive because they have angle lie in the second quarter. And we are talking about sine. And sine is positive in the second quarter. Super clear? Wow. I suppose...
I didn't understand why like the result is positive.
Because sine, so half angle lie in the second quarter. Is clear this idea for you or no? Half angle theta over 2 lie in the second quarter. This idea?
Yes.
Yeah, I know very, very, very well que sine in the second quarter is positive. Yes or no?
Okay, yeah. Thank you.
Okay. So I predict, because we have 15 minutes, okay, we are doing, so the equation gets complicated part. We continue doing Tuesday, no? So Tuesday is not due day for the, is maybe Thursday. Okay, I need to change this. Don't worry, we have it. Everything gonna be okay. Only you need to focus it in my subject. Okay. The Thursday, yeah, Thursday is Thursday, March 3rd, no?
Yeah, for everything, Professor.
For everything, I need to change, Alex. I need to change. I predict that because this situation happened, no? Because it's, pero no, it's for me it's fantastic because, okay, so now the thing that we are doing Tuesday is finish the review and start new chapter. I don't care. We have time, no, to start new chapter. Just the beginning, no, the first part, but
yes, we have.
Entonces, I extending the due date for the reading test and the online test to the March 3rd. Okay? Feel comfortable. Only working.
Okay.
It's my goal. Okay, let's move on to the okay, I need in this moment to explain very well this part. I need my famous chichi. I need my famous chichi. And the second page. Because we practice now a conversion, for example, the formulas, the horrible formulas for the conversion product to sum or sum or different to product, no? So I want to explain in detail this idea. For example, the first example that we have is sine A theta times cosine 4 theta. What formula are I using, Professor? Well, I'm using this sine cosine, right? It's the formula that allows us convert product to sum. Entonces, 1/2, bracket, whatever you want, cosine, 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 a ver, sine, sine, sorry, a ver, sine, sine, es sine, sine. Es sine, sine what? Sine addition. Addition what? 8 theta plus 4 theta, 12 theta. Plus, another sign, subtraction, 8 theta minus 4 theta. End the story, I finish. Close the bracket. Do you understand very well? Option B.
We just substitute in the formula.
That's it. That's it.
Oh.
That's it. This is no complication, no cuadra, no, it's just a formula. Got it? Likewise, it's doing number 43, que es sine theta. Wait. Sine theta. Sine 6 theta times sine 2 theta. So I try to find the formula that state the relationship between sine, sine. Sine, sine, it is the first one. 1/2 bracket. Cosine subtraction. 6 minus 2 is 4. The cosine 4 theta. Minus. The formula say minus. Cosine again 8 theta. Because 6 plus 2 is 8. That's it. Option C. This was option B. Got it?
Sorry, Professor. You wrote cosine of 4 theta, or it's 6. I can see it like inside of the parentheses.
Yeah.
Cosine. It's 4 or is it 6?
4.
Okay.
F4. F4. But this is an easy question, no? No complication because it's just apply the formula and that's it. Okay, entonces I propose you stop because we have time, no? Con this condition que I introduce, que we continue on Tuesday the review and start of course new chapter. We have time to stop here. Remember we finished 43, 44, 45, 47, 48. 2, 49, 48, 49, 50, and that's it. 50 questions we have in the review. Okay, super.
Yes.
Come on, working in your own homework is very, not very, but it's complicated. Okay.
Yes, it is. Yeah, I was doing like it's number 3. Homework 3 is hard, Professor.
Okay, no, the terminology hard or easy depending the people, right? The person. This is easy. No. They are thinking hard for everyone, no? But in this case, you try. This is you're a student, no? And the student investigate, working. This is the learning process.
Yes, it is, Professor. Thank you so much.
I know very well this because I study every day. Okay, guys. See you next day.
Okay, bye-bye. Have a nice day.
Okay.